Hi, this is Bill Hitchcock, and it's April 6, 2020, when we're recording the third part of our Chapter 8 stats clips. So what we're going to be looking at this time is some quartiles. So let me get you started with this. There's two different quartile functions, and what I need is some numbers here. So I'm going to type in 0, 1, 2, 3, and 4. And we've got the quartile.exe and quartile.inc. So we're going to try this out. We're going to type in equals quartile.exe or exclude, and I put in a parenthesis. My array is whatever it is that you're trying to get the quartiles for. So in this case, we've been working with salary data, so I'm going to choose the salaries, and I'm going to, either click on the blank cell, it'll ignore it, it's all right. That way, if we insert some more, we can have it. I'm just going to hit Shift, End, and Up. I, usually include the field name. I'm not going to do it here. So I've got that in there, but I do want to lock in this bunch of rows because I'm going to be copying that formula down for the rest of them. Type in a comma, and then for the quartile exe, there's only actually 3 parameters that I could put in here, but I'm just going to point to the number 0, hit enter, and I get a num put in. And now if I copy that down to number 4, the numbers that I'm getting is kind of in thirds, if you will. So here's like my bottom third, my middle third, and the top third of those salaries. So let's highlight all these cells and let's format them. Well, I can use this format painter. It won't hurt anything. We'll format all those. And we've got those in. All right, for the inclusive ones, let me show you how that one works. Equals quartile.inc. The array is the same as what we had before, the salaries. So Shift End Up. Type in function F4 to lock those in place. Type in a comma. Then you can see on this one, I've got the minimum value is 0, first quartile is 1, the median, third, and maximum value is number 4. So that's why I wanted to show you how you can reference these. And we've got, what's kind of nice about this is you've got the minimum 30,176, and you also have the maximum put in here. And you can, just use some count functions to find out, hey, is this right? Do I really have 25% of them that are less than or equal to 35,233? And we can, try doing some different things like what we had done up here. We could change this to 25% and see how some of these numbers kind of work out as far as using our range to do it. So it gives us more ways of looking at our data. And the second one here, the 45,955, is just telling you that's basically the median of the salaries, not equal to the average, right? It's slightly different than what we have here. If you want the median, there is a median function, equals median, and we'll go up and get all of our salaries. And there we've got it, 45,955. So half are above, half are below, and we can calculate out the median that way. So lots of stats so far. We've got some more things that we can do to help us kind of get a feel for our data and have a little better feel about how things are kind of skewed all over the place and where they tend to fall. So what I want to do next is I want to compute out the variance. So to do the variance, what you do is there's a manual way of doing it. And we want to kind of see, hey, are these numbers really right? or you just type in an Excel function and you get a number and you really don't have any concept of what that number is. So what I want to do is I want to find out how much does the salary differ from the average. So I'm going to take my first salary and subtract off, going all the way down to the end here. Shift N down, that'll get me down there faster. I want to subtract off the average. However, I want to do this for every single cell. So I'm going to hit function F4. So I always use row number 56, the average, and it gives me a negative 6,571. So I'm going to format that number just so it sticks out a little bit more. Right click, choose Format Cells. I'm going to go to Currency. I want to choose a red number with parentheses around it. I want to include the symbol. So if yours is set at none, you can go ahead and include a symbol if you like, and hit OK. And that way it sticks out. It's kind of, hey, there's a negative number. This person's getting paid below the average salary for our employees. Copy this down, and we can see all of our employees. This one's being paid, this director is being paid $35,771, higher than what the average is. This one's $37,000. And sure enough, if you look at their salary rank, that's the number 3 person that we've got. So I'm going to go all the way down to the bottom, and let's total all this up. So I've got my sum formula here. I'm just going to copy that over here. If I total it all up, you should get 0. And sure enough, it's given me a 0. If you don't trust me, I'll change this back to a general format. There it is, it's 0. And let's decrease that. So there's my difference from the average. All right, next what I want to do is I want to take that difference and I want to square it. So we'll say square the difference. So by squaring it, it's just equal to this number, caret, and raise it to the second power. And you get a huge number. But the idea is what we're doing is we want to basically, if you just add up the variance, every single data set that you have, it's always going to give you, the number minus the average is always going to, the total is going to be 0. All right, so that doesn't really tell us anything. But if we square these things, essentially what we're doing is we're getting a certain direction. All right, I want to know, I don't care if it's positive or negative, I just know that it's something different than what the average is. So if we copy that down, if I go all the way down to the end, we get some huge numbers here. So let's copy in our sum formula, and we'll widen this out a little bit further. All right, so I've got a big number there. So let's try this out once and find out what happens if we compute out, I need some space. Where do I want to put it? Sorry about all my moving around and whatever else. Maybe I'll put this off to the side here. So I want to compute out the variance, all right? And for my variance, it's equals variance, parenthesis, and hang on, let's try this again, equals var, sorry, the variance function, there's an old one that's kind of an outdated one. There's variance of the population, variance of the sample. We're going to go with variance of the population, .p, because I'm going to include all my records here. And I get a number like 387,000, or million, I should say, 469,641, which, In some ways, it's like, well, that's a big number. It must be that there's a fair amount of variance between all of our salaries. So if I take this number where we summed up all those squared differences, so we squared all those numbers, now I want to kind of take it back out. I want to compute out what's the square root of that. So if we say equals this number, raise it to the 1/2 power, or the other way of doing it is you can use this, there's a square root function, but you can, if you raise something to the 1/2 power, it's the same thing. And I'm going to format this. Oh, hang on. I did this wrong. First thing I want to do is I want to take this number that I have. Let's see. Let's format that. And then I want to divide that number by the number of observations that I have. And then if I format these numbers the same, that number is equal to what I computed out for the variance. All right? So let's try to summarize this again. If you sum up all the squared differences, the difference between the salary and the average salary, sum all that stuff up, we get this number, and then if I divide that number by the number of records that I had, this kind of tells me the average difference that we're doing for the squared, the squaring of those differences. It's 387 million. That's what I got with the variance. So finally, for a number that, you know, most people have probably heard more of is the standard deviation. So if I do the standard deviation, that's where I want to take this and do the square root of it. And I get a number like 19,684, which, if we type in equals standard dev.p of all of my salaries, I get the same number here. Let's just format it the same. 19,684. All right, well, I don't know. Maybe it helps you, maybe it doesn't. Let's try one more example just to kind of give you an idea about what we can do with some numbers. So let's type in new salary. And I'm going to give everybody the same salary, $50,000. Let's format that. And we'll copy this down. And if I go down to the end here, let's see, we've got the totals, the average, the min, and the max. Let's copy those over here. And wouldn't you know, the average is 50,000. All right, so now what we want to do is we want to take the salary, the difference from the average. We're going to square that. So I'm going to copy these over here. So my salary minus the average salary is down here. You get 0. If we square it, this, up arrow 2, it's also 0. We copy these all the way down. We're getting just a whole bunch of zeros. So therefore, when we, sorry, I went a bit too far. If I copy the totals, we're still getting zeros. If we take that number, divide it by the 50, we get a 0. If I take the square root of it, this caret to the 1/2, we get a 0. All right, so let's use our format painter. And finally, we're going to try out the calculated variance and the calculated standard deviation of my salaries equals variance P of all these salaries equals standard deviation of all of these salaries. We should get 0. So now we got to try to change a couple numbers. What happens if we just change one? Let's make it $100,000. Suddenly, we've got a slightly higher average. The variance, you can see, works out to be almost $49 million, and my standard deviation is 7,000. So just by changing one number like that, you can suddenly see how much more dispersed our salaries happen to be. So if, just try some different things, try 60,000 for instance, and see how much kind of variance and standard deviation start to change with some of your numbers, and you can plot some of that out. All right, a couple other statistics that we want to put in here is we want to compute out the kurtosis and something called the skewness. And we can take a look at a few things with some graphs and look at our charts and try that. So let's come over here, and there's a calculation for kurtosis. There's one for skewness. It's equal kurt, and your range is all the salaries. And the skewness is equal skew dot P, or of the skewness of the population. Highlight all those cells. And let's format them first with just a general format. All right, what these numbers mean is if that number is a negative number, it means that the distribution of our salaries is actually relatively flat. In other words, if you did a frequency count, a histogram, you would see that, plotting this out in terms of frequencies, how many of those that are close to the middle, and as we go farther out to the extremes, what happens to our count of all those salaries. So if it's a negative number that you're getting, it means that distribution is fairly flat. It's not very peaked, which is would be a positive number under kurtosis. So anything that's greater than 0, especially once it starts getting up to 1, 2, and 3, then it means it's really not very dispersed. All the numbers tend to fall right around that mean that we had. So let's take a look at, like, if I do this for the new salary and copy these over here. Here you can see the kurtosis is a very strong positive number. It's really peaked. The skewness, that tells you how far off to the tail your data lies. So let's say if you've got just a few small numbers, but then a whole bunch of really large numbers, then the tail of our curve is going to be skewed way to the right. If you've got a whole bunch of really small numbers, very few large ones, it's going to be tailed off to the left. So if it's a positive number, you've got this long kind of a long tail that goes off to the right. If it's negative, it's going to go the opposite way. So let's just try changing our new salaries just ever so slightly. Let's put in this one 65,000 and see what happens to our skewness, or our kurtosis, I should say. And since we've now have not all those numbers right up against that were equal to the mean, that number's starting to flatten out a little bit. We can change another number. We can maybe give a couple of our employees, oops, hang on, got stuck there and was going up near the top. Let's try putting in 40,000 and maybe a 35,000. So our total salary is the same as what we originally started with. And here you can see that these numbers are starting to change a little bit. And maybe let's just give it a comma format because we don't need to carry it out to all those decimal points. So there are the skewness. Notice it's almost perfectly distributed. We had a couple numbers that were below the 50,000, a couple numbers that were above it. So we got a 0 for the skewness on that. The kurtosis, it's a fairly peaked distribution. So that's what that number happens to mean. So you can experiment a bit with your data set just to kind of give you a better feel for some of these numbers. And then, like I say, it probably wouldn't hurt to include maybe an if statement to say, if the number is positive, tell the user what that number means again. That way they don't have to try to look it up or try to remember what those numbers are. You can explain it to them that way. So I hope this gives you a few ideas. The last thing that I want to do with this is we'll try making a couple of plots and see how the data turns out. We'll see if that works. And then finally, I'll try to record a number of these video clips to do this on one more file, and you can use some other data to work with it. So good luck with everything that we've done so far.